Good morning, good afternoon, and good evening. My name is Kevin Brady. I am a staff solutions architect here at VMware and the lead captain for the Tanzu Kubernetes Grid Basic Lab, which is HOL 223302. On behalf of myself and my co-captains, Mauricio and Peg, I thank you very much for taking the time out of your day to attend our workshop. I hope that you enjoy the workshop as much as Mauricio, Peg, and I enjoyed building the lab. And I hope that you'll have the opportunity to take the lab live when they become available. Very quickly, I am going to do a quick introduction of myself, walk through the lab and the lab experience, and then we're going to jump into the instructor-guided lab. So once again, my name is Kevin Brady. I am a staff solutions architect here with VMware on the Dell Synergy Acceleration team, also known as DSAT. And I've been with VMware for 8 years now. Prior to joining VMware, I spent 20 years as a Unix operating system developer in the advanced development group at Bell Labs and then later HP Labs. I'm also part of the Tanzu Kubernetes subject matter expert team, as well as a member of the Office of the CTO and a V expert. I've been a hands-on labs captain for 5 years now. I've had the privilege the last 3 years of being able to support VMware's modern applications offering. And then a quick glimpse at who I am and what I do in my spare time. So top right, that is me at Disneyland. Bottom two pictures on the right are my two wonderful daughters. In my spare time, I spend most of my time with my daughters. And as you can tell, we're big Disney fans. The last picture is from the Disney Merry Christmas party. So jumping into our lab, Mauricio, Peg, and I had an absolute ball building the lab. Learned a lot, great experience. And again, I hope that you really have the opportunity to take the lab and really do enjoy it. Our lab is going to be featuring two clusters. One is called the workload cluster, and one is called the management cluster. The workload cluster is where you're going to be deploying your applications. We will deploy an application in this workshop. The management cluster is where all the resources are running for things like the API server, database, and the scheduler. We have pre-created the lab for you because creating the lab would take more time than this workshop allows and would consume a great deal of resources. Within the lab cluster, we have two worker nodes. In the management cluster, we have one worker node. We've deployed a load balancer, the NSX load balancer, formerly known as Avi. And on each of our workload nodes has a single control plane. Again, taking a look at the lab that we have built for you. TKG uses what we call desired state configuration. So I tell TKG, or also known as Tanzu Kubernetes Grid, what the desired state of my cluster is, and then the automation in TKG will maintain that desired state configuration. Within our lab, as I mentioned, we have a single management cluster, a workload cluster, and two worker nodes. In the lab, we'll show you how we can scale those workload clusters up and down. Important to know is that our workload clusters are cloud native conformant, CNCF conformant Kubernetes, which means that your developers can take applications, YAML files, Docker containers, and run them as is on TKG without any modifications, because it's the same Kubernetes that the CNCF has certified and that you can download from CNCF Foundation. Quick overview of the VMware Tanzu portfolio. Tanzu is a family of products and services that are all made to work together seamlessly to provide you with a platform for modernizing your applications with a common goal, and that is to deliver better software to production continuously and with high quality. You can think of our portfolio in a few different buckets. There's the build bucket, which has our Spring runtime, as well as the Tanzu application catalog, formerly Bitnami. The Tanzu build service, which allows your developers to push code without having to worry about containerizing it or including the applicable libraries. Build service will pull all that in for you. As well as Harbor, our source code repository. We'll be looking at Harbor in this workshop. The control plane is VMware Tanzu Mission Control, which is our single pane of glass, which allows you to administer and manage any CNCF conformant Kubernetes cluster. We'll also, in the Tanzu Labs, in our hands-on labs portfolio, we also have a lab that will delve into not only observability by wavefront, which gives you end-to-end observability from the application all the way back to the infrastructure. And lastly, Tanzu Service Mesh, which gives you a global namespace to tie together all your applications and services. Our networking is provided by Antrea, another project which VMware has placed into the open source community. And we also deployed the NSX load balancer for you in this lab, also formerly known as Avi. We'll be focusing on the runtime in this lab, which is Tanzu Kubernetes Grid, which is our CNCF conformant Kubernetes. We'll also take a look at logging and monitoring using Fluent Bit. And other labs will look at Velero and Sonabui. Velero is our backup and restore utility, and Sonabui is a utility that we've placed into the open source community to help determine if a Kubernetes implementation is conformant to the CNCF standard. It's very important to know that our products are built using the best of breed open source technology. All the technologies on the right are technologies that VMware has put into the open source community or helped contribute to. Most of them will be featured in this lab and other labs within the TKG offering in hands-on labs. Harbor, our source code repository, as I mentioned before. Cluster API, which is the automation behind creating and monitoring clusters, Kubernetes clusters. Velero for backup. Contour, which is a ingress controller. Sonabui, which tests for conformance to a Kubernetes cluster. Fluent Bit, which we have in this lab, which is providing our logging capability. Grafana and Prometheus, open source products that provide reporting. Again, looking at our Tanzu portfolio, you can see the different pieces of the Tanzu portfolio. In this lab today, we'll be focusing on Tanzu Kubernetes Grid. Tanzu Kubernetes Grid can be deployed multiple ways. You can deploy it on any infrastructure. So in this lab, we'll be running TKG on vSphere 6.7 U3, but you could also deploy TKG on a number of public clouds such as AWS, as well as our VMware Cloud on AWS offering. It's also available bundled within the hypervisor in what we refer to as vSphere 7 with Kubernetes. With vSphere 7 with Kubernetes, TKG is bundled into the ESXi hypervisor and managed through vCenter. And then lastly, TKG can be used as a service by Tanzu Mission Control. Taking a look at some of the other labs that are featured this year. This workshop is Tanzu Kubernetes Grid. We have a lab on Tanzu Service Mesh. Service Mesh is our product that provides end-to-end operational networking, visibility, and security, providing basically a global namespace for all your applications. across multiple clouds. VMware Containers and Kubernetes 101 on vSphere Tanzu is the sister lab to this lab, and it goes into an introduction of Docker containers, Kubernetes, and modern applications concepts. Tanzu Mission Control, as I mentioned, is our centralized management platform. It's unique in the industry, and what it allows you to do is manage any CNCF conformant Kubernetes cluster. Lab 2234 is an introduction to Tanzu Observability, formerly known as Wavefront. Tanzu Observability gives you unique ability to monitor an application from the infrastructure all the way out to the application itself. And then lastly, 223501 is an introduction of Tanzu's build service, which is the platform that enables developers to boost application development velocity by not having to worry about the tedious tasks of having to build containers and bind libraries. That's all done by Tanzu Build Service. Our lab consists of 6 modules. We'll be covering modules 2 and 3 today. Module 1 is largely explanation. It's all reading. Module 2 will be looking at working with TKG clusters and the TKG CLI. In Module 3, we'll deploy a microservice-based application on TKG, and we'll also take a look at the Harbor Image repository. We will not cover modules 4, 5, and 6 in this lab. And hopefully everyone taking this workshop today will be taking the Odyssey Challenge. Lab 223381 is our Odyssey Challenge Lab. VMware Odyssey is a new, exciting way to learn about our portfolio of products. It's a gamification of hands-on labs in which you'll be challenged to complete multiple tasks in order to complete the lab. In this workshop, pay particular attention to the following, because these will help you with the Odyssey task. How do we provide additional resources for our developers? How did we allocate a resource pool for our development teams? How do we move an application from our local instance to an image repository? How did we retrieve the application for deployment? And then lastly, how did we improve the availability and performance of the application that we deployed? Pay close attention. All of these will be covered in the workshop today, and they will assist you with succeeding in the Odyssey Challenge. So with that, I'm going to briefly pause the recording to switch over to our live lab. We've now switched to our live lab. This is the 223302 lab running in the hands-on lab environment. I've already started the lab. Because of the fact that the labs are not all pre-populated at this point, it would have taken about 12 minutes to start the lab. So I skipped ahead to our module 2, and the first thing we're going to do is take a quick look at what we've deployed for you. So we're going to open up a Chrome browser. We're going to go, and then we're going to open up our vSphere web client. We're going to log in using the credentials that have been already pre-populated for us. You can see here that we have virtual machines for TKG Cluster 1, which consists of a control plane and 2 worker nodes, and a management cluster, which consists of a single control plane and a single worker node. And here is the Avi controller that I mentioned before, the NSXT load balancer, which we'll be using in this lab for load balancing. Skipping ahead, let's take a look at how this would look at the CLI level. So we're going to click on the putty icon on our bottom window, and we're going to open up our Linux VM, which is called CLI VM. The credentials have already been pre-populated for you, so you don't have to actually log in. We'll start by typing in Tanzu cluster list. A handy tip when using the hands-on labs is you can highlight and drag text into your window to avoid typing. So Tanzu cluster list is a command from the Tanzu TKG CLI. And what this shows us is we have a cluster called TKC1. It's in a running state. It has one control plane virtual machine and 2 worker nodes. And it's running Kubernetes version 1.20. But you'll notice it only showed us the worker nodes. And that's because by default, Tanzu cluster list does not include the management cluster. If I want to include it, I use the command Tanzu cluster list, but I give it the option to include management cluster. And now as you'll see, in this case, it has included the management cluster, which you can see here is called TKG Management. There's one control plane, one worker node. Likewise, it's running Kubernetes version 1.20, and its role is that of the management cluster. Handy tip to know when you're using Tanzu is if you ever get stuck, Tanzu help will give you a list of all the Tanzu CLI commands. Likewise, if I type in help after a partial command, it will tell me more options about that command. So in this case, maybe I've forgotten the options of Tanzu cluster, and typing Tanzu cluster help will give me all the options that are available for that command. Another thing to note in the labs that are using the Linux desktop and the Linux CLI is that by hitting my up arrow on my keyboard, I can scroll through the commands that I've already typed in. That's handy for when you don't want to have to either copy and paste or retype in the command. It's also useful to find out what version of Tanzu I'm running. So I can type in the Tanzu version command, and that will tell me what version of Tanzu I'm on. That's useful to make sure that I am on the most recent version of Tanzu. When taking this lab, a tip is to make sure that you position your CLI window so that you can see both the vSphere window and the CLI. And that's going to be important because as we execute the next few commands, you're going to want to watch inside vCenter as we execute the commands. Now, if you remember when I did my Tanzu cluster list command, I only had 2 worker nodes. And that's pretty typical if I'm just deploying a cluster for a development team or for a test organization. But let's say our development team is in crunch mode and they need more resources than they currently have. I can give them additional resources by scaling my cluster up. And I do that with the Tanzu cluster scale command. So I type in Tanzu cluster scale, the name of the workload I want to scale, which is in this case TKC1, and then the desired state. So if you remember, I had mentioned that TKG works with desired state. That means I tell it what I want it to do, and it will execute to make sure that that state is maintained and achieved. So in this case, I have 2 worker nodes. I'm telling TKG, or telling Tanzu, I want it to scale up to 3 worker nodes. Now this is going to take a second, so please keep an eye on the recent tasks as well, because the CLI is going to automatically scale up. So with a little bit of pixie dust, a wave of my magic wand, and the magic of automation, what we're going to see is it is kicked off a automation pipeline, and it has cloned a virtual machine. So it's gone into my image catalog and gotten this image. So we're using Ubuntu OS image for this with Kubernetes version 120. So it's cloning the virtual machine, and in a minute, you'll see it start that virtual machine. You can see here, there's a new virtual machine on the list that didn't exist before. It's not powered up yet. It's still in the cloning process. Now, the entire operation of adding a workload cluster Takes between 3 and 5 minutes. So we're not going to wait. We'll come back and check on our cluster in a second. But as you can see right now, it's in the process of cloning and it's already created the virtual machine. If I type in my Tanzu cluster list command again, you'll see that it's going to tell me that it's updating the cluster. There are now 3 worker nodes, of which 2 are active. So the third worker node, and that's it. And you may have noticed that that virtual machine just got powered on. The third worker node is being initialized right now, and it will show workers 2 or 3 until that node comes ready. We're going to skip scaling it back down because you do have to scale it back up before you scale it back down. So while we're waiting, let's take a look at our cluster using some standard kube control commands. If you're not familiar with kube control or kubectl, it's a basic Kubernetes API command. In this case, what we're asking you to do is get the clusters that have been configured. And you can see we have a couple of clusters in the configuration. What we're using today is TKC1 as well as the management cluster. It's important to make sure before we do anything that we have the right set of credentials. So we're going to ask Kubernetes, we're going to execute the TKG cluster kubeconfig command, and we're going to tell it to get the administrative credentials for TKC1 for us. And has now gotten them and saved them. So it's gone out. It's gone out to TKC1 and it's gotten us the proper administrative credentials. We want to make sure that as we're going through and working with our cluster, that we have the right configuration. Next thing we're going to do is take a look at the available and current context. Think of a context as a logical grouping of cluster resources, such as your administrative credentials. So in this case, what it tells us is we have 2 available contexts that we can run in. The default context, the one we're running in right now, is as the TKC1 administrator. Remember, we just got those credentials a minute ago. This is also telling us that we have another context available to us, and that is for the TKG management cluster. Very important thing to realize is that Kubernetes works off the concept of current configuration, current context. When I execute in the current context. So if I were to deploy an application within this context, that application would be deployed on TKC1. If I were to change to the management cluster, it will deploy and use resources from the management cluster. But in this case, I want to make sure that we are using the TKC1 cluster. Another way of finding out that I have the current context is by typing in kubectl current context. And it will show me the same thing that I saw before. The asterisk here indicates current. And it has reaffirmed that we are in fact using the TKC1 administrative cluster. If we wanted to change or we were not in the right context, we would execute the kubectl set context command. In this case, what I'm telling Kubernetes is please set my context to be that of the TKC1 admin. When TKG created the cluster, it created a configuration file, which it will use for maintaining and updating. And if we need to redeploy, we'll check that configuration file. The Tanzu config server list command tells me the location of that file. You can see it when I created this cluster, it created a directory called .cube-tkg. And it placed in there a configuration file. Now we can't look at that file. It's not human readable, it's machine readable, but it's important to know where that file is. Let's take a look at the nodes that got created for us when we created the lab. So we'll type in kubectl get nodes. We'll see now that we actually have 3 worker nodes, our control plane and 3 worker nodes. So our scale-up operation has completed successfully. You'll see that the node that was added, XH9ZQ, is now ready. So if I scroll back through my commands and list my configuration, I should see that I have 3 worker nodes available. Now, if I need to scale that down, so my development team has told me that they're done with the need for additional resources, I can execute the same command and tell it that I only want 2 worker nodes. So once again, working at desired state, the Tanzu automation will go and look at the number of worker nodes I have. It will look at my new desired state, which is 2, and it will adjust accordingly. Now, the delete operation or the scale down operation is a lot quicker because, as you can see right here, all it did is power down, delete the virtual machine. And if we check, it's already completed. So the scale down is much quicker than the scale up. Let's now take a look at some of the other resources that were deployed for the lab when we created it for you. You'll see we have a number of nodes running, but they're all running as they're all system services. So I have nodes running in the Cube system namespace as well as Tanzu system logging. That's our Fluent Bit application that's going to be providing the logging that our logging and monitoring tools will be processing from. Module 4 in this lab will go into more detail onto Fluent Bit and vRealize Log Insight, which is the tool that we'll be using for looking at the logging information. We can also take a look at the number of services that were started for us. So if we use kube control get service, and again, we're using the -A telling us to get everything, regardless of namespace, you'll see it's deployed several services for us. It's deployed, you can see the Entrea networking, a cloud controller manager, DNS, and our metric server. You'll notice that none of them have external IP addresses, and that's because we don't need to access any of those services externally. They're all system services. Module 5 will go into lifecycle maintenance of the cluster, but just to go through that very quickly here, if a new release of TKG becomes available from VMware, I'm going to want to update my management cluster to get the latest and greatest version of TKG. I do that simply by downloading the files from my VMware account, placing them in my vSphere in my vCenter, and then executing the Tanzu Management Cluster Upgrade command, which will then go and upgrade the management cluster. And this will all be covered in more detail in Module 5. After I've updated my management cluster, I use the same process to upgrade my worker nodes, and I do that with the Tanzu Cluster Upgrade command. Kubernetes is a rapidly moving, rapidly evolving technology. The Kubernetes Foundation releases 3 to 4 versions every year. So it's very important to know what releases are available, what release I'm on, and what release that are available to me. And as you can see here, it's telling me that there's several versions available. And it also tells me whether they're compatible with my current version. So you can see true and false telling me that it's compatible or incompatible. And that's the conclusion of Module 2. At this point, if you'd like to take a break, this would be a great place to pause before we move on to Module 3. So feel free to, if you need to take a break, need to stretch your legs, get a beverage, great place to stop the recording, pause the recording, and then restart as we go into Module 3. In Module 3, what we're going to be doing is deploying a microservices application using something called Spring Pet Clinic. We've already logged into our CLI VM. Let's take a look at the application we'll be deploying. So we're going to change directory into our applications directory, and we're going to take a look at the Pet Clinic app. We're going to take a look at the application that we're going to be deploying. Another useful tip within the Linux within the Linux CLI is the ability to tab out. So I type in a few letters, I tab out, I type in a few more, I tab out again, and it fills it in for me. So two handy things to remember when dealing with the Linux CLI is the ability to tab up and down for your command list, as well as the ability to use the tab key to expand the command line. If I take a look at my application here, let's look at a couple of things here. Replicas is telling us that I want 2 copies of this application. So when I deploy this application, I'm telling Kubernetes I want to create 2 copies. I'm telling it what image I want to deploy and where I want it to get it. Harbor is our image repository, which we'll talk about a little more in a few minutes. But for now, just keep in mind that this is the image that we will be retrieving from Harbor. Scrolling down further, you'll see we're also telling it to deploy a load balancer. What the load balancer is going to do for us, it's going to advertise on the port we specify using the protocol we specify. Load balancer is not only going to split the traffic between our instances of the application, it's also going to give us an external IP address. So before we deploy, why don't we create a separate namespace for our application? Think of a namespace as a logical resource pool. I can give developers namespaces, and within that namespace, they have not only have separation, but it's a great way to give them a separate resource pool. So they're getting their own separate resource pool and their own separate namespace. It's also very handy for tracking the application because now my pods are not going to be mixed up with other pods. So if you remember when I did the list of all the pods before, there were literally 30 pods there. If I deploy an application, it's going to get lost in that display of applications, and it will be much harder to track. So I'm going to create a namespace. I'm going to call it Pet Clinic. I can now deploy my application using the kubectl apply command. This is telling Kubernetes to execute this YAML file, petclinic.yaml, which is what we looked at a moment ago, and to deploy it in this namespace called Pet Clinic. We can now look at that namespace and list the pods that are in the namespace. And you'll see that it's in the container creating state, which means that it's initializing and creating that container right now. So if I take a look again, you'll see that the pods are now running. So the pods are up and running within 23 seconds. As I mentioned before, we told Kubernetes to get the image from something called Harbor. Harbor is a source code an image repository that was developed here at VMware and placed into the open source community. And Harbor has a lot of unique capabilities that we'll talk about in just a moment. But for now, let's log in and take a look at where this application came from. Harbor works off the concept of projects. Think of a project as a repository. I can create projects for development projects. I can create a project, in this case, called library, that I can use as a public library for images. We've created one called Trusted Project, where we'll put our trusted images, and Untrusted, we'll put our untrusted images. And then as you can see here, we created one for the WordPress application. We create a project as simply as clicking on New Project and then assigning it a project name. If I take a look at my library instance, where I told it to go and get Spring Pet Clinic, you'll see that I see Spring Pet Clinic under here. You'll notice this column called pulls. A pull is when I request an image from Harbor. So if I ask Docker to get an image from Harbor, that's called a pull. So if I click on my Spring Pet Clinic application, you'll see a couple of things. This pull command, if I highlight it, hover over it, you'll see it's got the command that I would use to pull this image from Harbor. We'll talk about vulnerabilities more in a minute, but one of the unique features of Harbor is that it does image scanning. So in this case, it's told me I have 51 total vulnerabilities, of which 1 is fixable, 5 are critical, 6 are high, and 7 are medium. We'll talk more about that, the concept of vulnerability scanning, in just a minute. But returning back to my Pet Clinic application, everything appears to be up and running and everything's good. My development team gets a call saying that people are having a difficult time logging into the Pet Clinic because there's only 2 instances of that running. I can create additional instances of that by telling Kubernetes I want to scale that application. In other words, I want Kubernetes to create additional instances of that application for me. I tell Kubernetes to do that by scaling the deployment. If I now take a look at my Kubernetes deployment again, you'll see that it's already added another instance for me. Now, this is fine for temporary situations because what I've done is I've added another instance to the running image. But let's say our development team needs to update Spring Pet Clinic, and then they redeploy it. Now, what would happen if they were to update it and redeploy it? Well, let's take a look and let's redeploy it and see what happens. So let's say, for example, our development team has updated Pet Clinic, and then after updating it, they redeploy it. Now you'll see that it didn't change anything with the deployment, but it didn't change the service, but it changed the deployment. So what did it actually do? It deleted one of our pods. Because remember, inside the YAML file, we told it we wanted 2 instances running. Kubernetes works off desired state. So when I reran my YAML file, it achieved desired state, which was 2. So I probably don't want to, in a production environment, dynamically scale up unless it's only going to be temporary. The proper way I would do that would be by updating the YAML file. So let's take a look at what happens when I update the YAML file and redeploy it. So in this case, what I've decided to do is I've decided from testing that the optimum number of replicas for Pet Clinic is actually 4. So what I'm going to do is I'm going to update my YAML file, and I'm going to say that from now on, when I deploy Spring Pet Clinic, I want it to deploy with 4 replicas. So let's redeploy it and see what happens. Again, you'll notice it didn't update the service, which is our load balancer, but it did change the deployment. And you'll see right now that it's already created 1. And I have 1 running and 1 in the container creating state. And now I have 4 running. So now I have 4 instances running. I will always have 4 instances running because I've updated the YAML file. So if I redeploy the YAML file, I will redeploy it with 4 instances. The last thing we'll show here, and this is not recommended, but as a good example of the power of Kubernetes, is I can edit my pod dynamically. So what it did is it opened up whatever the default editor was, which in this case is VIM. And in here, I can now dynamically modify this file. Keep in mind that any change I make to this file will become effective if I do a W, if I write it and quit it. As soon as I write and quit, Kubernetes will apply whatever changes I made to my running file, which is incredibly dangerous for 2 reasons. One is I can mess up a running file. Secondly, I have no version control of that change. It's very important to make sure that I maintain good version control. So if I look at my YAML file, I can tell that I have 4 instances running. If I were to update this dynamically, that change does not get reflected back in my static YAML file, and somebody might be confused between the current state and what's stated in the YAML file. If you remember, we mentioned that we deployed a load balancer. So if I were to go and get the service and say, get me the service, it will give me the address of the load balancer, which in this case is 192.168.130.100. If I go to that address, excuse me, if I take that address and paste it in a web browser, go to that address, you'll see that's my Spring Pet Clinic application running. And I've hit the address of the load balancer, which was 100, and then the load balancer is redirecting me to the application. Let's take a few minutes and explore more about the Harbor Content Registry. As I mentioned, Harbor is a project that VMware has placed in the open source community. It is an image repository, and there are many image repositories such as GitHub, but let's take a look at some of the things that make Harbor a bit unique. To start with, if I take a look at my configuration, you'll see I have the option of using the internal Harbor database for authentication or something like LDAP. I can also allow self-registration, which is fine if I'm running Harbor as a local project, but probably not advisable in production. I can determine who can create a project. I can make the registry read-only. I can add a white allow list. If you remember, we saw an image that had vulnerabilities. Not all those vulnerabilities may be important to us, so I can create a white list of known good vulnerabilities or things I'm willing to allow. And scrolling down, I can also enable webhooks. A frequent use of Harbor is inside a CI/CD pipeline. And inside a CI/CD pipeline, I could then use webhooks, so I can write a pipeline that will automatically push and pull images from Harbor. I can also configure project quotas. Because Harbor is taking up disk space, I want to make sure that no one project takes up too much disk space, and I can do that by setting quotas. So I click the project I want and edit it, and I can set project quotas for those projects. As I had mentioned, and clicking the Harbor Lighthouse anytime takes me back to my main page, I have the concept of projects. In this case, I have multiple projects here, as you can see. If we click on library, you'll see I have 6 different repositories inside my library. If I look at my image called Alpine, you'll see I have an image called Alpine. It has the tag latest. We'll talk more about tags. What tags allow me to do is assign a unique identifier to an image. So let's say that my development team or the Alpine development team has come out with a new version of Alpine. If I keep calling everything latest, by default, Docker will take the tag name latest and not take what the image I potentially want. Perhaps I want the version 1 of Alpine or the version 2 or the version 4. Or perhaps I'm doing testing and I have an Alpine blue and an Alpine green that I'm doing testing. The tag allows me to uniquely identify that image so that I can pull and use the correct image. Again, the pull command here would be what I'd use to pull it. And you can see that this was scanned for vulnerabilities, and there are no vulnerabilities in the Alpine image. So let's take a look at an image that has some known vulnerabilities. We'll go back to our library, and we'll look at an image called Cured 64. You'll see that it hasn't been scanned yet. I can scan it by selecting it and clicking the scan button. You'll see it's queued for scanning. So Harbor has queued up the job for the scanner and is now scanning it. And in a second, you'll see that the application shows that there are 14 vulnerabilities. If I hover my mouse over them, you'll see that I have 1 critical and 4 high. If I want to go deeper and I click on the image itself, you'll see that the image is unsigned. And then you'll see a list of the vulnerabilities. If I click the chevron, I'll see what the description of that vulnerability is. It also tells me this is version R3, but this vulnerability has been fixed in R5. So I got a lot of information here about the vulnerabilities in my object. We talked a little about the concept of having an image in this thing called a tag. So let's switch back to our CLI and take a look at what that means. By typing in Docker images, I can see a list of all the images that are sitting here in my local Docker image cache. These are images that are available to me on my image, but not available to anybody else. And you'll see here I have a number of images. It tells me where it pulled the image from, whether it's signed or unsigned. And in this case, it's telling me, or forgive me, it's showing me the tag, signed, unsigned, version 4, latest. Those are tags. What we're going to do now is we're going to see how easy it is to tag an application. And we're going to use an image called BusyBox for this example. So let's take a look at our Docker images again, but let's narrow the list down to only look at BusyBox. And you'll see I have a couple instances of BusyBox, one from Harbor and one that I pulled from another repository. So let's see how easy it is to create a tag. The Docker tag command is going to establish a relationship between the image BusyBox and a tag or an instance. So in this case, what I've done is I've told Docker to apply a tag to the image in the Docker cache called BusyBox, which is this image. And I've given it a tag. In this case, it's the name of the repository, our Harbor repository. I want to tag it with as untrusted project BusyBox HOL. All I've done is established a tag in my local image. So if I look again, you'll see I now have one tagged as HOL, but this is just sitting in my local image. If I want to put this out in Harbor so other people can access it, I have to do something called a push. And what a push does is it tells Docker to take this image with this tag and place it in the repository. If we go back to Harbor and we look at BusyBox, you'll see, in fact, we now have that image with the tag HOL. So now you'll see that we have 2 instances of BusyBox here with 2 different tags. So when I go to get a copy of this image, I can specify the tag and get the instance that I want. Next, let's take a minute to talk about something called signed and unsigned images. Another unique capability of Harbor is that Harbor can serve as what's called a notary. I may want to make sure that my developers only use trusted images. So I want somebody to verify that image. I've run a vulnerability scan. I verified where the image came from and that it has no vulnerabilities. I'm now going to apply a signature to that to say that that's the version of that image that I trust. I can establish something called content trust in Harbor. And I do that quite simply by going into configuration and saying, I want to enable content trust. So we've enabled content trust on our trusted project repository. Inside there, we have multiple versions of images, some which are signed, some which are unsigned. You'll see here it's not scanned. You'll see here that this image is signed. You'll see here that our QArt image is unsigned. So in theory, we should not be able to pull that QArt image because it's not signed. So let's test out our change to the registry and try pulling that unsigned image, which should fail because I've enabled content trust. And surprisingly, we didn't get the result that we thought we would. It actually pulled the image. The reason for that is that we also have to enable content trust for the Docker host, in this case, our CLI VM. We're running Docker on our CLI VM. We have to establish content trust with Docker as well. We established it for Harbor, but we didn't establish it for Docker. To establish content trust on Docker, there are two variables that need to be set. Docker content trust is a binary switch. 0 means no content trust. 1 means content trust is enabled. If I enable content trust, I have to point it to a content trust server. The address of the notary that contains the signatures, in this case, that's Harbor 01A, which is our notary as well as our source code repository. So why don't we set Docker content trust to 1 to enable content trust. We're going to export the Docker content trust variable. And now let's go back and retry that pull command again. And sure enough, we got the result that we expected. No valid trust data. So in this case, Docker went to Harbor, which is the notary, requested signature information, and found out that this image is unsigned. There's no valid data for it. And our pulling in image has failed. The last thing we're going to look at in this workshop is something called secrets. Very often, I'll have a situation where I need to pass some information to Kubernetes along with the application I'm deploying. It could be authentication information. It could be it could be a key, but it's certainly something I don't want to hard code in my application, because if I hard code it in my application, then anybody who has access to the YAML file is going to have access to whatever the secret was. So in this case, let's take a look at our YAML file and see what we've done differently from our other YAML file. And in this case, we've told it that it has an image pull secret. What that means is that when we execute this YAML file, a secret file will accompany it. Here is a great use case of cutting and pasting. You probably don't want to paste in this entire command, but what we're going to do is we're going to create a secret. In this case, we're just passing along some credentials and administrative. We're passing along an email, a username, and a password. If we get a list of our secrets, you'll see the secret that we just created. So let's create a namespace and deploy our application with the secret, and then take a look at it. So we're going to create a namespace just because it's going to be easier to take care of the application in its own separate namespace. Now we're going to apply the YAML file we just looked at. Now let's take a look at that YAML. Let's take a look at that deployment. Kubectl describe pods is a very useful command for debugging. It's going to give us a lot of information about the pod. If you remember when we did a get pods, it really didn't give us much information. It gave us the name and the runtime. In this case, what it gives us is a whole lot of information about where that pod was deployed, how it was deployed. In this case, what we're interested in is seeing that it deployed it with a secret. So it deployed it with the secret. We could, if you choose to clean up your the deployment when you take this lab, you could do a cube control delete of the namespace. That will, however, take a few minutes. So we're not going to do it here. And that concludes our tour through Module 3. I'm going to briefly, again, pause the recording. So again, if you need to take a quick break, this would be a great time to do it as I pause the recording and switch back to the presentation. Thank you. So hopefully you got the clues for the Odyssey game. As you again, to refocus, think about how did we provide additional resources for our developers. So in Module 2, we talked about how we could grow our workload cluster. How did we create that separate namespace? So in Module 3, we created a namespace for our pet clinic application. How did we move an application? So how did we take that application and put it in the image repository? Likewise, how did we retrieve when we did our test of signed and unsigned? How did we retrieve the application from our image repository? And then lastly, with our pet clinic application, how did we improve the availability and performance of the application? So think about those for your challenge. The modules we didn't cover. Module 4 is a quick run through of some of the integrations and extensions that come with Tanzu Kubernetes Grid. Extensions include ingress control, log forwarding, which you'll see in Module 4, and that's Fluent Bit. We saw the container registry capabilities of Harbor. And we will, for monitoring, we'll be using our own vRealize login site. Module 5 is going to give you a walkthrough of the Kubernetes Grid installation process using the GUI, which is the recommended method. We'll walk you end to end through this and show you how simple it is to deploy both the management workload cluster in TKG. Module 6 is a walk through Octant. Octant is another project that VMware's placed in the open source community. And what Octant gives you is a great view into your Kubernetes workload. All the workloads that you saw in our lab all deployed as we expected. But unfortunately, it's never that simple. And sometimes things don't work the way you think they should. What Octant does, it gives you a developer-centric web interface for Kubernetes that gives you a graphic-based web console to go in and look at your applications and your deployments. And once again, these are the other Tanzu hands-on labs that we have this year. And we'd ask you to please take the survey. We really do take these surveys very seriously. They get looked at and we use them for improving our workshops moving forward, our workshops and our hands-on labs moving forward. So please take a minute to take the survey. And then lastly, from myself, Mauricio, and Peg, thank you for attending the workshop. We hope you have the opportunity to take the lab when it comes into the catalog. And we truly hope that you enjoyed the workshop today and you enjoyed taking the lab. Thank you very much for your time taking the workshop today.